So hey guys, welcome to the channel Learning Competitive Programming with CodeChef. So if you want to learn competitive programming and master data structures and algorithm, this is the prime location for you. Every week there are several videos regarding the CodeChef contest editorials as well as various videos which will enhance your skills in competitive programming. So if you are new to the channel, then please do subscribe to the channel and turn on the bell notification. So myself Chirayu Jain, and in the sequence series of binary search, we'll just come up with part 4 and we'll try to solve one problem regarding the concepts that we have studied in the binary search. The problem that we're taking is minion chefs and bananas. Okay, so let's discuss the problem based on binary search concepts. In the previous videos, we have discussed what is binary search and what are the two approaches, that is the iterative and the recursive approaches of the binary search, right? So now in this video, we'll discuss a basic problem regarding binary search, right? So let us understand the problem statement and let us see whether this problem is of binary search and how we can identify that. Correct. So the problem name is minion chef and bananas. So minion chef likes to eat bananas a lot, right? So there are n piles of bananas in front of chef, from each I ranging from 1 to n. For the ith pile contains ai bananas, right? So let us say that these are the number of piles. So let us try to understand the problem with the help of an example, right? So here we are taking this particular test case. So let us say that here are 3 piles that we have been given for bananas, and there are the respective bananas in each pile. Now chef mother wants her to eat the bananas and be healthy. She has gone to the office right now and will come back in h hours, right? So the mom will come in h hours. Every mom wants a child to be healthy and like to eat fruits a lot, right? So I think you can relate with this. So she's gone to office and will come after h hours, and chef would like to make sure that she can finish eating all the bananas by that time. So what does the condition here is that all the bananas should be finished before h hours. Bananas should be finished before h hours, right? So this is the whole summarized point of this particular paragraph, right? So chef has an eating speed of k bananas per hour. So how does a chef eat k bananas per hour? Each hour she will choose some of pile of bananas, right? Any of the pile of the banana, and if the pile contains at least k bananas, then she will eat k bananas from it. Otherwise she will simply eat the whole pile, right? So it is important to note here that it won't eat any more bananas during this hour. So what chef can do is chef can eat k bananas per hour, and if that pile contains k bananas or less than k bananas, so she eat that pile, not the other pile, not any other pile. But if the pile contains more than k bananas, then she only eat k bananas out of that pile, and the rest she will eat in the next hour, right? So let us try to understand. So let us say that the value of here what we have been given here that the h hours, right? So here we have been given the h hours, the hours which are after which her mother will come, right? So here are the particular banana piles we have, and we need to do, right? So in the last statement it has been given that chef likes to eat slowly but still want to finish eating all the bananas on the time. Therefore she would like to choose the minimum k. So we'll get to know why we require minimum over here, that it would need a k such that she'll be able to eat all the bananas in h hours, right? So we would like to choose a k, that is the speed of eating bananas per hour, such that all these bananas are finished before 3 hours, right? Less than or equal to 3 hours, right? So how we can do this? So we need to determine k, right? And the fact that it is given minimum k is because k can increase, right? I can choose a value of k as 10 to the power 2, that is 100, right? So in the chef can eat 100 bananas in 1 hour. So what chef will do? First he will spend 1 hour over here, because in each pile she'll eat all the bananas and then just be stagnant. He'll not move on to the another pile. That is the important condition we can see over here, right? So she'll eat the whole pile and would not eat any of the bananas after that, right? So at least what we can drive a conclusion is at least she would require 3 hours to finish this. Correct? Why? Because after eating this particular one banana, the rest of the hour she'll not eat the rest bananas. She'll be stagnant because this pile is finished. Then after banana, she'll move to this particular pile, and then it will get finished. And then this particular pile, then this will get finished, right? So she'll move step by step to finish the bananas. So at least she would require 3 hours. But is that the value of k? Because k can be 100. Similarly for 1000 also. If chef has the capability of eating 1000 bananas per hour, then she'll eat 1000 bananas, and similarly she'll require 3 hours. So we should get the minimum value of the k here. Not 100, not 1000. What is the minimum value of k? Minimum bananas that she can eat per hour, so that this condition is fulfilled and all the bananas could be eaten before this particular time interval. Let's say how. So let us say if we take two bananas per hour, that is the value of k is 2. So what she do? She eat 2 bananas per hour. So one banana can be easily finished in an hour, and then she will wait. So 1 hour is occupied. Now for the next pile, there are 2 bananas. So 2 bananas she'll eat, and then 1 hour is occupied, and she'll eat the 2 bananas because the speed is 2 bananas per hour. And for the last one, she'll eat 2 bananas out of 3. So 1 banana is left in 1 hour. Since 1 banana is left, so she will require another 1 hour to eat that. So how many number of hours are required? That is 4 hours for k equals to 2. Right? So can we do it more efficiently? Because it is requiring 4 hours. Can we get minimum time at some other value of k? Let's see. If we go for 3, right? So let's rub this off, and let's see if we go for 3, what could be the possible answer. So if she eats 3 bananas per hour, then this particular pile is finished in the first hour itself, right? How? Because 3 bananas are more, and she need to eat only 1 banana in this pile. So in the first hour, she'll eat this particular banana. Similarly, for 2 bananas in this pile, she'll require only 1 hour because she has the capacity of eating 3 bananas per hour. Now for the last one also, she can easily finish this particular pile in 1 hour because she has the capacity of 3 bananas per hour. So in 3 hours, she is able to finish this whole set of piles. And what is the value of k required? That is k equals to 3. For the value of k, which is equal to 3, she requires 3 hours. And similarly, we can see when we are taking the value of k as 100 or 1000 or something bigger, the output would be 3. So what is the minimum value of k? That is k equals to 3. For k equals to 3, she can finish all of this piles of bananas before the time, or equal to the time, right? So this is how we need to develop a solution, and this is how we are thinking that how we can formulate this approach. First of all, the problem statement should be very clear to you, right? There must be no ambiguities regarding the problem statement. So we have understood the problem statement, we have understood the thing that why we require the minimum k. Generally, when we see the problems of minimum and maximum values required, so generally we develop an idea of binary search, that this problem might be related to binary search, right? So let's try to focus on how we are developing the solution and how we can draw the important points and takeaways from this particular question, right? Okay, so now let's try to understand the approach of this particular problem, right? So what we have been mentioned, we need to find a k, minimum value of k, such that where k denotes the speed, right? So it can eat k banana, the chef can eat k bananas per hour, right? This is the speed, and we need to find the minimum value of k such that all the bananas in the piles are eaten, and it is before h hours, right? So the time is less than or equal to h hours. So this is the whole problem statement. So if we simplify this problem statement, so what we can get? So first thing to simplify is how we can denote that these number of hours are required to eat the bananas, right? So let us say that we have an array A, which denotes each element of this array denotes that there are some AI bananas in that particular ith pile, right? So we have this array A, and in this array at ith position we have AI bananas, right? So for each pile, what will be the number of hours required? So let us suppose we found the value of k. So for the ith pile, how many hours would be required, right? So if a chef can eat k bananas per hour, and we need to find out in how many hours the chef can eat AI bananas, so simply we will divide it by k. Right? So let us say that if it has 3 bananas in the pile and the value of k is, let's say, 1. So how many hours it will take to eat all the 3 bananas? That is 3 hours. It is simple, right? It is simple. But let us say if chef can eat 2 bananas per hour, right? So the value of k is 2, then how many hours it would require? So you would say that it is 1.5 hours required, right? So it is not exactly the same case, because we know from the problem statement that chef eats bananas per hour, and if it does not get any further bananas in that hour, so it remains, it does not move to any other pile, right? Either it eats the whole pile if the number of bananas are less than the value of k, otherwise it eats the number of bananas, and then in the next hour it eat the remaining bananas, and then it become vacant. It will not go to the next file, right? So for it can eat 2 bananas at 1 hour, so it will eat first 2 bananas, and then 1 banana is remaining, right? So it will eat 1 banana, and it will take the whole 1 hour for that, right? So total number of hours will be 2 hours. So how we can find that if it is not completely divisible, then how many number of hours it would take? Simply what we will do, we'll take the ceil value. What does the ceil value denotes? That the value, if there is a division or something, so we'll take the upper bound of that particular division, right? After the division, we'll take the upper bound value. So if it is 1.5, we'll take 2, correct? So this is the important case. We'll take this of this particular division, we'll take the ceil value of that, right? And for how many times do we need to take the division and the ceil value? So for I equals to 1, let us say for the first element till n, because we have n piles starting from the 1. So for all the piles, we need to sum these value, that is ai divided by k, and we'll take the ceil value for that. And for which ith element? For all the i's, right, starting from the 1 till n, for the n piles, we need to calculate this. This particular expression denotes the total number of hours required, the total number of hours for this particular value of k, which is required to eat all bananas. And according to the problem, this particular formula will be valid if it is less than or equal to h, which denotes that the hours after which her mother will come in the home, right? So the summation of ai divided by k and the ceil of that for I equals to 1 till n must be less than or equal to h. So this is the important inequality here, which we can derive from the problem statement. Okay, so this is the case. And if we look at the constraints of the problem, if we look at this constraint, so what is the length of this particular a, that is the pile array? It is ranging to 10 to the power 5, right? So we can take the sum of that. We can take the basically the sum. We can form this inequality. We can check every time. But ultimately, what is our end goal? Our end goal is to determine this value, the value of k. Here we are not determining any value of k, right? We are just assuming that we got the value of k and we put it in this inequality just to check that this is holding true. And if this k is like is some correct value and this is coming true, then that possibly be the answer. I am not sure, but that can be the answer. But we need to find the minimum value of k for that. So next goal. First goal is conquered, that is we found some inequality, some equation which can lead to the solution. We got the point. But the next goal, which is the end goal of a problem, that is how to determine this value, how to determine k. and that also the minimum value of k, such that this equality holds true, right? So how we can do this? There comes the binary search, right? So we know that k, the constraints, as you can see, k can range to 10 to the power 9. Because what is k? K is the number of bananas chef can eat per hour, right? And in the problem we can see that any element in the array can reach up to 10 to the power 9. The size of the array is 10 to the power 5, but any element in the array can reach to the value that is 10 to the power 9. So it is possible that chef can eat that number of bananas in 1 hour, right? It can be possible. So we'll take the worst case, and it can happen that the value of k can range to 10 to the power 9, right? So if we consider all the values from 1 till 10 to the power 9 and check this inequality for all the array members, that is 10 to the power 5, so what will be the time complexity? That is 10 to the power 9 into 10 to the power 5, which is equal to 10 to the power 14. It will result to time limit exceeded. It will not just get to the whole problem. It will give you some subtask correction, subtask AC, but for the whole problem you will not get AC. You will get time limit exceeded. So the first solution that comes to our mind is for all the values of k, right, starting from 1 till 10 to the power 9, we'll check that this inequality, when this inequality is holding true, right? So whenever it is true, right, starting from the 1, because we are starting from the lowest, right? So whenever it is true, we'll break down from the loop, and that will be our answer for k. So one loop for 10 to the power 9 and another inside loop for 10 to the power 5. So in worst case, it will result to 10 to the power 14 for the worst case, right? But how we can develop an intuitive solution to get this k easily done, right? So here comes the binary search. Whenever we require minimum maximum value, we generally go to the binary search, that hey, binary search, you get our answer, right? So what we can do, we can start from that for a possible value of k. So first of all, we'll take the left as 1 and right as 10 to the power 9 or something, and then calculate possibly the mid. What will be the mid? Mid will be the value of k. So for each value of k, we'll just do, that is L plus R minus L by 2, that we have seen in the previous videos, that why we are calculating the mid like this, right? And with this particular k which we are getting as a mid, we'll use this formula. We'll use this in this particular equality to get our answer, right? So we'll check that for all the values in the pile that is of range 10 to the power 5, right, in the array, when this is holding true, we'll sum all the values, and we'll check that if it is less than or equal to h, right? So if it is less than or equal to h, that possibly can be an answer, right? So what we can do, if it is less than or equal to h, if the summation of all of this particular result is less than or equal to h, that might be our answer. So we'll take that into an answer, and what we will update, right? So if, let us say that yes, the value of h is something like 5, and we got our answer as 3. So yes, it can be an answer, right? So what we will do is we will update the right portion, that is the r. We'll update the r and we'll set it as 3. Is there any less value than 3 that we can get? Because we need to find the minimum value of k, right? So is there a value which can be available, which can result to a sum which is less than 3, so that we could possibly do better than this, right? So we'll update the right particular pointer as this particular 3. If it is greater than 5, so what we will do, we'll update the left pointer. Because we need to get a value which is smaller than 5, correct? So this is how we will develop the approach. So let us just quickly review it once so that it can be clear. So point number 1, what we will do, we'll just uh, for every mid, for every value of mid, we'll just use this inequality, right? So with this inequality, if the summation of all of this ai divided by k seal of this for I equals to 1 till n is resulting less than or equal to h, that means that can be an answer. So what we will do, we'll update the answer as mid. The mid, that means the value of k that we are getting, right? So we'll update the answer with this mid, and what we will do, we'll update the right pointer. So what will be the right pointer? Right pointer will be mid minus 1. So we'll check that if any other value can come into this, right? So if not, if it is not less than or equal to h, that means there is not a value, there is no possible value that we are getting. If it is greater than h, that means it is not existing, right? So what we will do, else we'll update the left as, we'll update left as mid plus 1. We'll update left as mid plus 1. So this is the whole possible thing that we can do, right? So this is an interesting problem. If we are able to crack this particular formula, and then if we can apply, if we know the constraints very properly, that this is ranging, the value of k is ranging till 10 to the power 9 and it is 10 to the power 5, so we can easily crack that it can be done with binary search. So what will be the time complexity, right? So what will be the time complexity? That is equal to 10 to the power 5 into log of 10 to the power 9 base 2. So it will be somewhere that is 10 to the power 5, and it will be somewhere regarding in the range of 10 to the power 5, 27, 28, 29 into 10 to the power 5, right? So it will be ranging to 10 to the power 5 power. Earlier it was 10 to the power 14. So you can see the difference, right? 10 to the power 14 is much greater than 10 to the power 5, right? So you can see the difference. Okay, so this was the approach of this particular problem. Now let's just try to get it once more clear with the help of the code in C++. So one small request to you, if you are like a beginner and just developing the intuition for binary search, just try out the code of this particular problem with your own understanding and see that wherever the mistakes you are doing, and then you can refer the video again, right? So this is the best practice that you can do. Also, one more interesting thing to you, that is Unacademy platform. So Unacademy platform has huge variety of educators which are 7-star coders on CodeChef and various other competitive programming platforms, and are champions in this field. They are IOI medalists and they are world champions in ICPC. So these educators are teaching live on the Unacademy platform. So what you can do, you can just download the Unacademy app and go to this app and learn from these educators just for free. Also, if you want, you can take the plus subscription as well. So you can use my referral code, that is Chirayu Jain, to just log in and register on Unacademy app, right? So it is a very helpful app, for the beginners who are just initiating with this competitive programming, or for the mediocres who are just want to excel, right? So there is something that you can learn from this app. So just download the Unacademy app and get started with it. Okay, so we are coding the solution on CodeChef IDE. So let's start off with the solution, right? So first thing, we have the number of test cases, so we'll enter the test cases, right? So for each test case, we have two values. First, that is n, which denotes the number of piles, and the second one is r. Let us take r variable, right, which denotes that in what time the chef's mother will be returning home. So we'll input these variables and we'll make an array which will store the number of bananas in each of the pile. So we'll make a banana array and the size n. So we'll take it as long int. Okay, so now let's take the input for this each banana pile. So we'll input it as right. So we've inputted all the values. Now what will be the step? So first of all, we'll take low and high. So low will be 1, right, and high will be let us take long int, both of the variables as long int, right? So low will be 1 and let's say high will be 10 to the power 9. So we can write it as 1e9, 10 to the power 9. So according to the binary search code that we have seen in the previous video, so let's try with the iterative one, right? Because it is most commonly used. So while L is less than or equal to H, the first thing, while L is less than or equal to H, first thing is we calculate the mid. So let us say the mid that we are calculating, let us name it as K, because it is ultimately the value of K that we are getting, right? So it will be low plus high minus low by 2, right? So you can just see it, right? So it is low plus high minus low by 2, correct? This is the value of mid, or we can say K, that we got. Now for this value we need to calculate the sum. This is the value of K that is now, and we need to sum up the according to the equality that we have seen in the approach, right? So for int I equals to 0, I less than n, I plus plus, it's small n. Let's make a variable that is sum, long int sum, which is equals to 0, right? And now for this sum, what we'll do, we'll just sum up the value, the ceil value. There's an inbuilt function ceil, and what will sum? The divide of ai, here we can say the banana of I, the ith pile of banana, divided by K. So one thing here, if we take the integer value, then ultimately it will result to a round of number integer. It will not take the point. So what we need to do, we need to typecast it to double, right? So that it will take the point and then it can round up to its top value. So what we will do, we'll take double, we'll typecast it as double and take the value that is first banana I, and it will divide by the typecasted value W, that is K, right? So now it will take the ceil value up. So we'll take the sum of these values. The sum is taken. Now what we need to do, we need to just compare it out. So if this sum is less than or equal to the R, then what we will do, firstly we'll take the answer, right? So what is the answer that we can get? So first of all, we'll initialize our answer, that is long int answer, and we will take that answer is equal to K, first of all, because the sum is less than or equal to R, so it might be possible that this can be the answer. And we'll update, what we will update, we'll update the high with K minus 1, that is the mid minus 1. Otherwise we do the same thing, that we'll update the low with K plus 1, and after that we will return the answer after that. So out of this while loop, right? So we'll return the answer that we're getting. Okay, so let's try one random case out. The test case is 1, size of the array is 3, the value of R is 3, and the files are like this. So let us see, this is one of the, I think, sample test case. So let us see that what is the result coming out, what is the minimum value of K, and what are the errors that we can just resolve it out. Okay, so it is showing time limit exceeded. Maybe we have done something which is encountering this loop again and again, right? So what we have done is we have taken the T, we have taken the R, we have formed the array banana, and we have made ln h, right? And what we're trying to do, we are trying to run a while loop. While L is less than or equal to H, we are just making the mid, that is L plus H minus L by 2, and then we are running this loop, calculating the sum. If sum is less than or equal to R that we are getting, then we'll update answer as K, h will be equal to k minus 1 and L will be equal to k plus 1. Sorry, so it will be equal to k plus 1, and then we'll just run it again to just see that whether the answer is coming right or not. Okay, so it is successfully executed and the answer to this is 3. So what is the minimum value that we should take? That is 3 of k. So I think this is more or less the solution. So let's just try to submit this particular code on CodeChef platform. So let's just paste the code over here, choose the language as C++, and then submit it, right?